KNOX City Council's stormwater harvesting scheme at Dobson Park and Tim Neville Arboretum has been designed to reduce mains water consumption by utilising stormwater harvested from surrounding catchments for the irrigation of these outstanding facilities. It is important that key assets around this site are maintained following the provided guidelines, so when viewing this video, make sure you have a copy of the user manual handy. The user manual includes a detailed site layout plan.
So you can see how green this cricket pitch is. That's because we're harvesting the stormwater and treating it and then irrigating back onto Dobson Park and the Tim Neville Arboretum.
The scheme is broken into 5 distinct stages. Stage 1 houses a Stormceptor on the corner of Dorset Road and Francis Crescent.
The stormwater comes down Dorset Road into this diversion pit. The flow is split from the diversion pit into the junction pit. From the junction pit, it then goes into the Stormceptor. So the Stormceptor has 3 chambers. The first chamber is where the primary filtration's done. So we're getting rid of the Coke bottles, cigarette packs, chip packets, your gross pollutants and hydrocarbons in the main. From here it comes into the second chamber. So in the second chamber, that's where the coalescer lives. Now the coalescer is a filter that comes up the guide rail using the chain. Now to maintain, you'll pull it out of this chamber, hold it over the first chamber and flush it until all the mud's gone and clean water comes out. Then once you've vacuumed off the pollutants in the tank, you'll replace it back down the guide rail and it will sit into the cone at the bottom. The coalescer polishes the water prior to going into the third chamber, which is the pump station. So this is integral to the Stormceptor, and there's pump 1, 2 and 3 in here. The pumps then pump into the valve chamber. The valve chamber is the last hatch. That contains your non-return valves and isolation valves prior to discharging up to the tank on Dobson Park. So this is the control panel for the pumps within the Stormceptor. That's pump 1, 2 and 3. So we've got an alert light on top, so that'll go when there's either a fault or an alarm. 2 little antennae here are for speaking with pump 5, the main control system for the site. Inside the control panel, we have the controller for pump 1 and 2, which are the large pumps providing transfer of water to the Dobson Park tank. That should normally be set on auto for each pump, and the controller will start and stop when required. There's also a level display displaying the level of water inside the Stormceptor. This also works in with the controller to start and stop at the appropriate times. Coming down to pump 3, now pump 3 is a small pump for the large circulation loop of the stormwater harvesting project, providing constant flow through the wetland. So that should always run on auto. Moving down to the bottom, you've got a fault light. Also, your green light will tell when the circulation's running.
Moving to stage 2, which provides substantial water storage and high-level filtration.
So we're up here at Dobson Park now, and this is where the water is pumped from the back of the Stormceptor once it's treated. So this is the inlet from the Stormceptor. At peak flow, that's running at 60 litres a second into the top of the tank. Then this white pipe here is the overflow pipe, which flows back to the wetland. Then this small pipe here is the low flow circulation loop, which runs through the wetland also to keep the base flow running. The Pure Rain system behind me in this application is used for treatment and irrigating to the sports fields. You have the inlet pipe coming in from the tank through the Cascade vertical multi-stage pressure pump. Then we go through 100 micron screen filtration, then through UV sterilisation to make the water safe to irrigate prior to going into the irrigation system. Okay, so this master control system inside the pump 5 enclosure actually has a touchscreen display which you can pull most parameters of the whole project out. The home screen here, you can see the irrigation pump set is idle because we're not irrigating. Any alarms will list down the left-hand side. The pressure of the pump system and the level of the tank are shown in these bar graphs on the right-hand side. As you drill into the menu, by pressing the menu button, you can see an overview of the irrigation system. So that's your tank, the pumps, the pressure of the system, and then the flow irrigating. You can see a whole site overview, which in here you can see everything from the wetland levels to the pumps on the Stormceptor, the Bafflebox position, and the recirculation pump set. You pull up the alarm menu, which has a list of alarms, historical and current. You can read log data, so run times, any curves and plots there are, and many other things. This and more detail can be viewed on the web page for the NetVital login. The login details for this and the web page are in the user manual. If there is any alarms or faults that aren't referenced in the user manual, contact AKS and we can provide technical assistance. So that's the master control panel. You'll also see another little screen on the right hand side. That's the UV system status monitor. On this little screen you can see the UV penetration. It's at 0% at the moment because the irrigation system's not running. You can also see a run time. All this information is also recorded in the master controller. So on the back of the enclosure of the Pump 5 system, you can see here we have a vent. This is riveted in one corner and bolted in the other three. That swings away to replace the tubes in the UV system. This here is a drain from the back of the screen filter for when you're manually flushing.
Now we're heading across to stage 3 of the scheme. This is where the SPEL Bafflebox primary treatment system is located.
The Bafflebox is installed on the Tim Neville Arboretum side of the stormwater harvesting project to treat the top catchment. Now that catchment comes into a 375 diameter inlet pipe through the Bafflebox out to the wetland. So two unique things about the Bafflebox is the SPEL view cover being the only clear cover on a gross pollutant trap, meaning that maintenance and inspections are easy. You can see straight through from the top. And the other is that you treat 100% of your flow, so no first flush. So inspecting and maintaining the unit is as easy as lifting the SPEL view cover, which is made easy with the gas assisted struts. Inside the system with the cage, you lift the top hatch, suck out the pollutants with the vacuum truck. Then you can lift the bottom hatch and take the sediment out of the base. Important thing to note is that the hydro weir isn't obstructed and can float up and down freely.
The fourth stage is the wetland for tertiary treatment of the stormwater.
The constructed wetland is a biological form of stormwater treatment, which is taking out the soluble nutrients such as phosphorus and nitrogen. Also brings back an aesthetic, which brings the community together.
And then the fifth stage is the storage lake, which also has the recirculation pump and flow control valve.
We're here at pump station number 4. Pump station 4 is between the wetland and the storage lake. And this completes this small loop recirculation between the two. What it does, it takes the treated water from the back of the storage lake, then transfers it to the top of the wetland to keep the wetland flowing and make sure the water's treated perfectly. This is the control panel that drives pump station P4. The pump station is an Ultima pump station with an automatic pump that circulates the water between the storage lake and the wetland. From a maintenance point of view, just ensure that the sediment doesn't build up around the pump. If it does, suck it out. This is the control panel for the recirculation pump, pump station P4. You see on top it has a light which will illuminate if there's any faults or alarms. A little antenna which communicates back to the master control system. Inside the control panel, there's a touchpad for this single pump. So this pump should always be on auto. That's automatically controlled through the brains in the system. And this here is a level display, which indicates the depth of water in the storage lake. When completing maintenance on any of these control panels, ensure that the isolator is not touched. That is the mains isolator, the big red one. Also, don't open the inner door. If these works need completing, use a qualified electrician. So we're at the end of the stormwater harvesting process, and the last piece in this puzzle is the flow control valve. The flow control valve is at the back of the storage lake, and it controls and regulates the large recirculation loop. So when it's not raining and the Stormceptor is not taking fresh inflow from the main drain, this valve will open and allow a recirculation flow to go back to the Stormceptor to go through the process again. This is a control panel for the flow control valve. You can see on top of the cabinet there is the little antenna which is communicating with the master control system, and that's where it's controlled from. Inside this control panel, very simple display. You have a valve open and a valve closed light and a three-way selector switch. This selector switch should always be on auto. During your 3 monthly maintenance and inspections, cycle the valve from fully opened to fully closed before returning back to auto to ensure its operation. The other thing to make sure is that the well that the valve is in is completely dry and there isn't any water sitting in the base. If there is, suck it out. KNOX City Council's Tim Neville Arboretum and Dobson Park Stormwater Harvesting Scheme has been immensely successful. AKS is proud to be part of this solution, working with Council from design, through construction and now onto maintenance. What we've been able to do here is provide unique, out-of-the-box solutions, from the stormwater treatment with the Stormceptor to the integrated control system. Being able to take pressure off the potable town water supply by using an alternative harvested stormwater supply has brought livability to this park in ways not seen before.